Aloha kako. My name is Paoa Kannegiesser, and I am currently a graduate student at University of Hawaii at Manoa, pursuing a master's degree in coastal geomorphology. In my research, I model sea level rise and create maps that highlight the areas along the coast of Oahu that are more likely to flood. Sea level rise is directly related to the amount of carbon dioxide in the atmosphere. According to NOAA, the last time that the amount of carbon dioxide was as high as it is today was more than 3 million years ago. And at that time, the sea level was 50 to 80 feet higher than it is today. This is roughly the height of a 5 to 9 story building. So, it is extremely important for all of us, especially those that live on an island or along the coast, to be able to visualize what different levels of sea level rise look like. Flooding maps are a very powerful tool to see what areas are prone to flooding. But when looking at maps like these, it is very important to consider how they were generated and the uncertainties or the accuracy of the data used to generate them. Many researchers have been generating coastal flooding maps in the past by modeling the flooding of a specific area and have considered the uncertainties related to the 3D model of the area. However, it is also important to think about the uncertainties related to the ocean surface surrounding the area. These uncertainties are harder to account for. The objective of my project is to use data from a regional ocean modeling system to incorporate this uncertainty so that we can better assess the vulnerability of low-lying areas along the coast, which are prone to flood because of the rising sea levels. If you live or have lived in a coastal setting, imagine the highest tide you have ever seen. Think about if the streets were flooded, how little space there was at the beach to hang out, and how far inland the waves were reaching. Because of rising sea levels, this scenario will be what a low tide will look like in the future. Now, keeping in mind that this is now a low tide, imagine the high tide. Imagine the highest high tide, and on top of that, imagine a big swell. What will happen to the beach? What will happen to the boats in the marinas? What will happen to the buildings along the coast? The use of ROMS data has allowed me to generate two different kinds of maps. In one, I illustrate different flooding depths for a single probability value. For example, these maps were produced at a probability value of 80%. This is to say, we're 80% certain that this will be the daily high tide. The maps that are on screen now show the total area flooded represented by the shades of blue, and the different shades represent flood depth. In the second kind of map, the different colors represent the different probability values for a single flood depth. For example, the maps that I am showing now illustrate flooding of 1 foot of water. The area highlighted in dark blue represents a flooding probability value between 100 and 90%. The area highlighted in light blue represents a flooding probability value of 90 to 80%. Similarly for the orange and yellow areas. Let's look at the maps for the hypothetical scenario of 6 feet of sea level rise. In both of these maps, we can see that with only 6 feet of sea level rise, most of the Waikiki Peninsula is flooded, and the coastal flooding could extend up to Date Street, which is highlighted in red. Next time you drive around this area, try to imagine what it would look like if the coastline was cut off here. With these findings, I hope to do two things. One is to provide communities and their decision makers a powerful tool that will help determine innovative construction, planning, and development measures to prepare us for what is to come. On the other hand, I hope to raise awareness to reduce the amount of sea level rise as much as possible. The time for us to take action is long overdue. We know that the sea level will rise, we just don't know by how much. To reduce the impacts of sea level rise in the future, we must reduce our carbon footprint today. Carbon footprint refers to the amount of carbon dioxide that we as a person or a group of people put into the atmosphere due to the consumption of fossil fuels. Some ways we can reduce our carbon footprint are: avoid buying plastics as much as we can, reduce the amount of red meat that we eat, eat locally produced foods, and choose to walk or bike whenever possible. It will take all of us to make a difference. Mahalo.